أعزائنا طلاب الصف الثاني الثانوي وتحديدا القسم العلمي، بنرحب بيكم في حلقة جديدة من برنامجكم تبسيط العلوم. كل الأسئلة والأجوبة والنماذج الامتحانات المختلفة والتدريبات العملية والتطبيقية اللي بتبحث عنها عزيزي الطالب ستجدها معنا في هذا اللقاء مع مادة الماث. والنهاردة وصلنا معاكم لجزئية مهمة جدا، هنتكلم عن الاستاتكس. معانا بارت 1 هنشرحه، والبارت الثاني إن شاء الله هنستكمله في حلقة أخرى. النهارده معاكم ومزيد من الشرح والتبسيط للاستاتكس، ومعانا اللي مشرفنا في الاستوديو مستر عبد الناصر جابر عبد الله، مدرس ومعلم خبير بوزارة التربية والتعليم في مادة الماس. مرحبا بك.
اهلا وسهلا.
اهلا بحضرتك معانا، ودايما بتنور استوديو تبسيط العلوم بشرحك الجميل جدا. نبدأ مع حضرتك.
شكرا لك. Okay, my dear students, let's go to the slide 1 here. We have unit 1 in statics. Okay. What is the statics or the branch of statics? The science of the statics concerned with solving all geometrical problems related to the equilibrium of bodies. Okay. What is the equilibrium of bodies? We have here, my dear students, we have here something here, calculator as example. When we put this example, this calculator here on the table, that is means that it has a power or a force effect on the table by the weight, and the table affect the calculator here by another force but opposite in direction and equal in magnitude. Okay, so it is equilibrium. So let we see the definition of the scientific statics. It is a science of statics concerned with solving all geometrical problems related with the equilibrium of the bodies. Force. What is the force? The force is defined as the effect of a natural body upon another one. Okay, let's see what is a body, a natural body and another one. If we have this calculator and I'll effect on it by a force in a point, so it is move. This is the natural body and this a natural body else, and I effect with this natural body on this one from this point, so it moved now. Okay, let's move the next slide here. What is the effect of a force? Depends on the following factors: magnitude of a force, secondly direction of the force, and thirdly point of action of the force and its line of action. What is the resultant? The resultant means total force, resultant of two forces meeting at a point analytically. If we have a force here like F1 and another force F2, and there is another angle between them alpha, and we have the force effect at a direction of angle theta inclined by angle theta on the force, we called it F1. So these two forces effect at a point which is O, and we would like to find the R. R is the resultant of the two forces. We will use R, this rule, to find the magnitude of R equals square root F1 power 2 plus F2 power 2 plus 2F1 F2 cosine alpha. F1 is the first force, F2 is the second force, 2F1 F2 cosine alpha. Alpha is the angle between the two forces. Okay, to find the direction of the resultant, we will apply this rule: tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. F1 is the force that the resultant inclined on it. Okay, theta here is the angle which inclined the resultant on F1. Let's move to an example. Two forces of magnitude 3 and 3 root 2 Newton act on a particle, and the measure of the angle between their lines of action is 45. Find the magnitude of their resultant and the measure of the inclination angle with the first force. We have here the data. F1 equals 3, F2 equals 3 root 2, and alpha, the angle between the two forces, equals 45 degrees. Yes, this is force 1, force 2, resultant between them, and there is E alpha between the two forces. Theta is an inclination angle between R, the resultant, and F1. We will apply this rule. R equals square root F1 power 2 plus F2 power 2 plus 2F1 F2 cosine alpha. Yes, F1 equals 3, so we put 3 power 2 plus 3 root 2 power 2 plus 2 times 3 root 2 cosine 45. The answer will be 9 plus 18 root 2 multiplied by 1 over root 2 equals square root 45, which is equal 3 root 5 Newton. We have found that R is the magnitude. Magnitude of R equals 3 root 5 Newton. But we now need to find the angle of inclination, tan theta. We know that tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. We apply that. F2 equals 3 root 2 multiplied by sine 45 over 3 plus 3 root 2 cosine 45. The answer will be half. Measure angle theta equals, to find measure angle theta, you have to use your calculator and write or press the button shift tan half. Shift tan half. The answer will be approximately equal 26 degrees 33 minutes and 54 seconds. Let's move to the second question. We have here, find the magnitude and direction of the resultant of two forces F1 and F2 in the following cases. We have special cases here. If the two forces are perpendicular, this is the first case, and the two forces have the same magnitude, this is the second case. If the two forces are perpendicular, like this one, we have here F1, and F2 is perpendicular to it, that means the angle between them equal 90 degrees, and the resultant is the force between them, and we have found that theta is an inclination angle between R and F1. Okay, we'll be back. We will find that F1, when it is perpendicular to F2, then the rule that give us the resultant equals square root F1 power 2 plus F2 power 2, and to find the angle of inclination on F1, we will apply this rule, which is tan theta equals F2 over F1. We have here an example. Find the magnitude and direction of the resultant of F1 and F2 in each of the following cases. F1 here equals 5 Newton, F2 equals 12 Newton, and the angle between their lines of action equal 90 degrees. So alpha equal 90. F1 and F2 are perpendicular and alpha equal 90 degrees. Then sine alpha equals 1 and cosine alpha equals 0. And we will apply this rule, which is R equals square root F1 power 2 plus F2 power 2, and then R equals 5 power 2, which is the first force, and 12 power 2, which is the second force, equals 13 Newton. Let theta the measure of the angle between R, which is the resultant, and F1, which is the first force of inclination. Tan theta equal F2 over F1. Tan theta equal F2, which is 12, and over F1, which is 5. And you press the buttons in your calculator, shift tan 12 over 5. The answer will be 67 degrees 22 minutes and 49 seconds. So the inclination angle R on F equals 67 degrees 22 minutes and 49 seconds. Let's move to the next question. We have here F1 and F2 equals 16 Newton. The measure of angle between their direction equals 120. So we have F1 equals 16, F2 equals 16, and alpha equals 120. We have here the F and F. We have F1 equal F and F2 equal F also, and alpha is the angle between them, and R is the resultant between them. This figure will convert from parallelogram to what? To a rhombus. Why? Because this side will be equal this side, so all sides will be equal. So it is rhombus now, and this angle will be alpha divided into two equal angles, which is alpha over 2 and alpha over 2. Okay? We can use the original rule, which is square root f power 2, f1 power 2 plus f2 power 2 plus 2f1 f2 cosine alpha. We can substitute f1 equal f2 equal 16 Newton here, and R will be square root 16 power 2 plus 16 power 2 plus 2 times 16 times 16 cosine alpha. Alpha is the angle between the two forces, so the answer will be 16 Newton. We notice that F1 equal F2 equal R equal 16 Newton, and the resultant force bisect the angle between the two equal forces. What should mean? R inclines by an angle of measure 60 degrees with the line of action of each other. So we can say that cosine alpha over 2 equal half R over F, and R equal 2F cosine alpha over 2. So we can apply this rule when the two forces are equal in magnitude. We can find R using this rule, which is 2F cosine alpha or half alpha, and the angle equal cosine alpha over 2, which is half R over F. So the angle of inclination of R on F equals alpha over 2 or half alpha. Let's move to the special case. If the two forces have the same line of action and the same direction, here we have a line, straight line, and F1 has a direction and F2 has the same direction, so they move together on the same direction. And of course measure angle alpha between the two forces here equals 0, and cosine alpha equals 1. So concentrate with me, my dear students. We have here two forces. Okay? We have here two forces. This force and this force have the same direction, so they move together like that, and they have the same line of action. What is the angle between them here? The angle between them here equals 0. Yes, 0 here. If we put them like that, they will be perpendicular, and the angle between them will be 90 degrees. But when their directions are the same, the angle between them will be 0 degrees. Okay, and alpha cosine alpha equals 1, and R equals the sum of the two forces, F1 plus F2. Okay, let's move again to the slide. Measure angle alpha, as we said now, measure angle alpha equals 0, cosine alpha equals 1, and by substitute in the resultant rule, we will find that R equals F1 plus F2, and the direction of the resultant is the same direction as the two forces. In this case, R is called the maximum magnitude of the resultant. We can call it the greatest value of the resultant. So when F1 and F2 act together on the same line of action, the resultant will be their sum, and we call it the greatest or the maximum magnitude of the force or the resultant. Okay. Number 2, if the two forces have the same line of action and opposite direction, like this. We have here two forces, first called F1 and second called F2, and they act on opposite direction but on the same straight line. So the angle between them here equals 180 degrees, and cosine alpha here equal -1. And by substitution in the resultant rule, we will find that R equals absolute value F1 minus F2. Why absolute value? Because the forces has no negative values. So we put this absolute value here to guarantee that the result will be positive. And R here acts in direction of the force of large magnitude. R is called the minimum magnitude of the resultant, or the smallest value of the force. My dear students, look at me and concentrate, pay attention carefully. The last time we talked about the two forces have the same direction, but now we will talk about the two forces have opposite direction. Let's say that F1 and F2. We have the angle between them here. It is a straight angle, so it is 180 degrees. And each of them acts on the same straight line, but in opposite direction. This direction is different from this one. So the resultant will be the difference between them, F1 minus F2, or even F2 minus F1. And we put absolute value to guarantee that the result will be positive. We haven't have a force equals negative value. So we put the absolute value. Okay? Let's move to the slide again. Okay, R acts in direction of the force of large magnitude. If F1 the larger, then R will be the same direction as F1. But if F2 is larger, then the resultant will be take the same direction as F2. Let's go to example here. Find the magnitudes of the minimum and maximum magnitudes of the resultant of the two forces of magnitudes 4 and 7 Newton. We have here maximum magnitude. We have agreed that R will be maximum if they 4 and 7, we find the sum of them. So 4 plus 7 here equals 11 Newton. Acts in the same direction of the two forces, because the two forces here have the same direction. And minimum magnitude of R will be absolute value 4 minus 7, or we can put 7 minus 4. The answer will be 3 Newton. Acts in direction of force of magnitude 7 Newton. Why acts on the same direction as 7 and not 4? Because 7, it is the greatest force, and we agreed that the direction of the greatest force will be the same as the resultant, or resultant will take the same direction as the greatest force, which is 7 here. We have two forces of magnitude F and 4 Newton act on a particle, and the measure of the angle between their directions is 120 degrees. The magnitude of their resultant equals 4 root 3 Newton. Find the magnitude F and the measure of the angle that are formed with F. Notice, my dear students, here that we have F as unknown. So we will use, or we write the data, F1 here equals F, and F2 equals 4, R, which is the resultant, equals 4 root 3, alpha, which is the angle between the two forces, equals 120 degrees. In the rule, R power 2 equal F1 power 2 plus F2 power 2 plus 2F1 F2 cosine alpha. Some of you asked me, why didn't we put the square root here? My dear students, when you have unknown inside this part, which is the right part, it's prefer to put R power 2 to put away the square root. We have here R equals 4 root 3 power 2 equals F power 2 and 4 power 2 plus 2 times F times 4 cosine alpha, which is 120 degrees. We have here on the right side F power 2 and F. You have to expect that this equation will be second degree equation or quadratic equation. So try to solve it carefully. Let's move the second one. We have here F power 2 here plus we have to multiply 2 by 4 cosine 120 to find that it will be negative 4. So put negative 4F beside F power 2, and 4 root 3 power 2 will be 32, and as an equation you put them in the other side by the negative degree. F power 2 minus 4F minus 32 equals 0, and we will factorize them. F plus 4 multiplied by F minus 8 equals 0, and by equalize these two factors by 0, the answer will be F equal negative 4, which is refused because it's negative, and we haven't a force equal negative value, and the right answer will be F equals 8 Newton, because it's okay to be F equal positive number. To find the angle between F and R, we will use the rule tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. Tan theta equals 4 multiplied by sine 120 over 8 plus 4 multiplied by cosine 120 degrees. The answer will be 1 over root 3. So we will find that R make an angle of measure 30 degrees with F1. You have to put in your calculator the button, press the button shift, then tan 1 over root 3 equals 30 degrees. We have here exercise, the first one complete. The effect of a force on a body is defined by the following. What is the following? He asks you, the effect of a force on a body is determined by the following. The effect of the force, we have defined it. Yes, the effect of any force depends on the following factors. The first factor is the magnitude of the force. The second factor is direction of the force. And third one, the point of action and the force and its line of action. Second question here, the vector of the resultant of the two forces F1 and F2 is equal to what? If we have two vectors F1 and F2. Concentrate, my dear students, that F1 here as a vector, not as a magnitude, and F2 as a vector. So F equals F1 plus F2. We put F here as a resultant equals F1 and F2 or plus F2.
تمام مستر عبد الناصر، كنا سعداء جدا بلقاء حضرتك النهارده، وبكده بنقول بارت 1 في الاستاتكس خلص، وشرح حضرتك كان جميل جدا وكان مبسط، استفدنا كتير منه. شكرا يا فندم.
شكرا.
أعزائنا الطلاب، حتى نلتقي معكم في حلقة جديدة من برنامجكم تبسيط العلوم مع مادة جديدة ومقرر جديد. شكرا لكم.